Hello, everyone. Thank you very much for coming to see my talk. I'm Sebastien. I work at Red Hat in the OpenShift team and on all things about automating Kubernetes applications. This talk is about a project that we're building across a lot of different teams that's called the Operator Framework. It contains a lot of different pieces that I'm going to be talking about, and today I'm going to be focusing on building applications with a piece of this framework, which is called the Operator SDK. So the talk will be a few slides and then a main chunk of demos. That's how I prefer doing my talks. And then we'll have time for some questions at the end, like 10 minutes or something. All right. So what's an operator? So obviously, I'm assuming a bit that you know what Kubernetes is, a platform to deploy applications and to manage them in an easier, more distributed fashion. But more importantly, Kubernetes gives us a common API. It gives us an API that allows us to express objects in YAML and then interact with these objects to create new things. And not just application objects, but not just Kubernetes objects, but any objects that you want. And an operator is an application that leverages that API, that runs on top of Kubernetes as a container, and can therefore automatically manage that application. The goal, it's a design pattern, I would say, that was created by CoreOS before the Red Hat acquisition. And the goal there was to replicate what we call cloud services. When you use a provider like AWS and you want a Postgres database or a MySQL database or a queue, you call an API and you get a fully managed service, let's say RDS, for example. And you're able to launch RDS and interact with it and decide when it's going to go to a new version. But other than that, you don't care about what's happening operationally behind the scene. Of course, there's exceptions to that. But overall, that's the global idea. And the goal here is to do the same thing, but with any open source application, or not open source, on top of a common platform that's Kubernetes. That way, we can bring that same style of cloud service that you can find boxed into these different cloud providers on any cluster, whether you run it on-prem, whether you run it on your laptop, whether you run it on a cloud provider itself. Since they don't give you all the services, you might want to be able to adapt them, look under the hood. The promise that open source gives you about being able to go in your software, looking at it, kind of disappears with these cloud services. And the goal of this is to bring that back, to be able to give that full panel of possibilities to the users. So the goal here is, if you've in the past started using Docker as a developer, you've had the privilege of being able to go from having to know how to install something like Postgres, for example, just for your local development on your laptop. And you would have to configure it, go in the config files, figure out how to run it, figure out how to start it. And then, a bit later, you were able to just do it with one command called docker run. That ease of use is tremendous for development, but hasn't quite crossed over into the operational world yet. Despite all the promises of the platforms underneath, there's still a lot of domain-specific knowledge that each of these apps need to be able to run within a cluster without human intervention. And without human intervention is a complicated subject. It requires you to know your app very well and to be able to code all the operational knowledge somewhere so that when something happens, like, for example, an upgrade or a recovery or scaling up, scaling down the app, the operator, the code in the background, can do this instead of a human. So this basically is to bring day two operations to code. And so we decided to put this behind the Kubernetes API. Why the Kubernetes API? Because people are already familiar with it if they use Kubernetes. They want to use the same tools, like kube control or anything else that takes advantage of these APIs. And they want to be able to easily launch an app and then utilize it and have users not worry and be able to just query the server about status, understanding how it's running, but not worry if a node goes down, for example. The way you build an operator, though, is complicated. I write on the slide, it's built like any other Kubernetes controller. It is, but that requires a lot of domain-specific knowledge. Again, not in that app, which you have, but in Kubernetes, which you might not want to go that deep, and you might not have the time to go that deep. And so the goal here is to be able to create a framework that we call the operator framework that encapsulates a lot of this boilerplate and a lot of these operations so that you don't have to rewrite them again and again, so that you don't have to relearn the ecosystem again and again. So in the operator framework, we have 3 projects. I'll be focusing afterwards on the SDK, but I want to present the 3 highlighted projects. There's a few more projects coming, but I'm going to focus on these here. So the operator SDK, that's where a developer starts. That's the tooling that allows you to scaffold a lot of code, to generate that code, to start using it. And of course, you do need to know a bit about Kubernetes, but not the intricate details. And you're able then to start writing your domain-specific code. Once you have that operator, you can use the SDK to package the operator as a Docker container, something that is universally runs. And then also you're able to test your operator. Because if you're going to write a system that needs to update itself, scale itself, then you want to not just write that domain-specific logic, but you want to absolutely also write all the tests that go with it, just like a normal software development, to be able to make sure that if I upgrade, if I change something within that operator, it's still going to be able to run. It's still going to be able to operate. And more importantly, I can actually use machines and APIs to test if my operators work. Then another concept that I'm going to demo a bit is what we call the operator lifecycle manager. Once you're in a world with a lot of these operators, you still want a way to manage them all, to easily install them, upgrade them, the operators themselves, and subscribe to, let's say, a stable channel or a beta channel or an alpha channel. And you want to manage what we call the lifecycle of these operators inside of your service. And I'll be demoing it afterwards, but that's what the operator lifecycle manager is for. Metering is another part of the framework. The idea here is to be able to collect metrics in a very granular fashion to be able to create usage reports across your operators or other applications. So it's based on Prometheus, but after that, you're able to do detailed reports. Imagine if I wanted to bill someone or know how much a team is using in terms of detailed resources. With the between the SDK and the metering, I'm able to build operators that send custom metrics, and these custom metrics can then be put in reports to be able to know, for example, what the average size of tables are, or how much CPU a certain part of an operator used, and all of these. So, demos. After the demos, I'll leave a bit of time for questions, but I think the demos are the more interesting part of this. So let me exit this. What I have here, running here is an OpenShift cluster, so Kubernetes. There's nothing running on that yet except the base components. And what we're going to go through right now is I'm going to be building a Memcache operator. So we're going to go through the steps that it takes to build a Memcache operators and why I'm taking these steps and why these exist, and then show you from 0 to 1 how to get Memcache running on that. Note that the user of these things won't have to do all these steps. This is about developing an operator. So these are the steps that a developer would take. So let's start. I have my. So first things we're going to do is we're going to set up a directory where we're going to be working. So that's I'm copying things out of this doc here. All right. So I have a tool called Operator SDK. I've built it. I've compiled it. It's installed on my machine. So I'm able to start by creating a directory for it with all the default code that gets generated and all the dependencies that need to be installed. That's akin of when you use a web framework like Django, for example. You would be running anew to go from 0 to something. And then it would install the dependencies. It would generate the code that you don't need to edit. So this should be quite quickly. Now we're done. So now I have a Git repository where I'm able to go in, and I have some base lines here. Then I need to start creating. This is an empty operator. There's nothing. It doesn't do anything, even though I've called it memcache. I'm going to have to start adding an API to it. An API in Kubernetes, the way you do it is you create what's called a custom resource definition, in which is a kind of a YAML that describes what you're allowed to do when you're talking to that API. And this is the code, basically, when I do add API to generate those custom resource definitions and be able to interact with. After that, I need to generate another piece, which you would call a controller. So a controller is a loop. That loop basically spends its time doing what's the state of the cluster, what's running, and if it doesn't agree with what's running, it's going to reconcile and fix that. So for example, if it's been told to run 3 memcache servers, it's going to look. If it finds only 2, it's going to start another one. And the operator's job is basically to do all that in a loop the whole time. That's the controller part. It goes, it looks, fixes it, goes back to looking. So now that I have these things, we need to put in some custom code. So let me show you the custom code. So the first thing, I'm copying existing code in there. We're going to quickly go in these files as well. So this is the controller, and then this would be the types. So if we look at this quickly, why did I copy this? Because when you first generate this, it asks you, what are the types of your API? In my case, I want a memcache cluster. So I need a size of my, I basically need the size of my cluster. The size is the parameter that I'm going to pass to tell it how big it should be. And then I also have to edit what's called the status. An operator doesn't just check something. It also writes back status about the state of the world. So in this case, the number of nodes that we would have. So these are 2 variables that I put in here. So size and nodes. These will be mapped to some YAML that I'm going to show a bit later. And then the other thing that I copied over is this controller. That's the nitty-gritty part. That's the actual loop that I talked about. The loop that goes and checks basically if everything's running. So basically, you can see it here. It gets the memcache instances. Oops. It checks for the instances. If it's not at the number that it wants, it'll create new pods. And that code here is written in Go. You'll see later that I'll talk about how you can write this in other ways than Go, but Go is the default way in which you can write this. And then the code that you write here is, depending on your operator, can be complex or pretty straightforward. This case, this is a very stateless application about just spinning up memcache and getting them down, so it fits in a couple of lines. Or, yeah, it's not that. It's a few hundred, but it's not that much. OK, so what do I do once I've copied these things? Well, first, we've edited the types, so I need to generate them. And so I said that an operator is a Docker container. We're going to be building that Docker container. So now we're going to take all this code that we edited, all this code that we added, and we're going to generate the container that goes with it. And I'm giving it I'm going to later be pushing it to Quay.io, so I'm already giving it the full name that it's going to have. So this is done. Now, let's see. There we go. I'm just changing the name. This dev deploy operator file down here is how you deploy the operator, and it was generated by the SDK, and so I have to edit it since I changed the name of the image, and you can see it here. So this is, for those familiar with Kubernetes, this is what it looks like. This is what a deployment for something in Kubernetes looks like, and this basically is the file that tells me how to deploy that operator. I've told you before that these are Kubernetes apps, just like the apps that they're monitoring. And so since I've done that, now all I have to do is push my image. It should be quick since I've pushed it already, but we're overriding it. Done. OK, so how do we get this right? What do we do now? So first, this is Kubernetes. So there's quite a few YAML files to deploy. There's the CRD, which I've explained. So in this case, it's the file that basically describes the API. That was generated by the SDK. Let me show you this. So this basically describes what how a memcache resource can look like and what I can send. So that needs to be first registered with the Kubernetes API server so that I can then tell it to deploy new memcache systems. All right, so we're going to be deploying these. Let me just show you. I'm going to paste all this quickly here. So here we're deploying the CRD, then what we call the service account, and also all the permissions and all the permissions that the operator would need within that cluster. And these are a lot of YAML files, and I'm going to show you what the Lifecycle Manager does for you later, which is the fact that you don't have to deploy all those YAML files. The Lifecycle Manager does that for you. But if you're in a pure development manual mode, that's what you're going to have to do. And then the next thing is we're going to actually deploy this operator. So now it's created. So I should be able to do kube control get deployment. And I can see the memcache operator. So there's no memcache running yet, right? Like if this is just the operator itself, I have now to instruct it to create a memcache cluster of a size that I want. So let's do that. So from now on, any user in this cluster that has the permissions can do this. It doesn't have to go through all these different pieces of steps that I went through. So what does this look like? Cat cache. Give me a second. All right. Not the right directory here. Example, memcache. This is where I created everything. And so if you cat deploy CRDs, this is it. This is the, oops, I've been typing on my other screen. Great. That's why I had to change directories. No need to change directories here. All right. So this small YAML here that you can see, this is all it takes to instantiate an instance of memcache. In this case, 3 servers. So if I kube control, if I do this, I created it. Now, if I get my deployments again, I get the pods. I should see my pods come up. There we go. What did I do wrong? It should be here. There it is. That's definitely it. So there we go, CRDs. This is the one we created a minute ago. The question is why it's just one. Good question. PC. Right, we're going to skip ahead but basically you can see the memcache pod running here, like right here. That's it. Why it's not a size 3 is a good question. If we have time, we'll get back to that. So basically, that's how it is. If you want to delete it, you delete the CR. If you want to instantiate a new one, that we can go. We can do that. That's a good idea. If we want to do someone that's called all things open, memcached, and we can create it. Oops. There we go. I've been editing this on the wrong one. That's why. OK. So here, deploy, CRDs. I've been editing this one. I've put all things open memcached here. And now I can create. Let's apply this one. And then now I can get pods. And there's my all things open memcache pod. So I have two memcache services running at the same time, all from the one operator. And if I kill a pod, it'll restart it. All right, we can try here, actually. There we go. Delete pod. Delete. Let's wait a few seconds. It's terminating. And while it's terminating, let's continue. So this is the SDK side of things. So you see there's a lot of manual steps, but what does it mean when everything comes together? What does it mean when you take that, when you take the operator lifecycle manager and you put it together with not just example apps? There you see. You can see that it was restarted. It's running again. Why? Because the operator doesn't want it to be dead. I told him that it needs to stay open. So when it all comes together, this is what we see. We have in this cluster, we have the operator lifecycle manager running, and you can see that it has, you have a list of already existing operators. That is something that in the future will be able to be modified very easily, and you'll be able to have all the operators you want. In this case, we have one etcd and one Prometheus operator. And I'm able to subscribe to these operators. I'm doing the same thing that I've been doing with the kube control, but inside of the OpenShift UI. And here I'm creating a subscription to OLM, and I say, I want my users of my cluster to be able to deploy etcd. And so I just started this. I can see that it is currently the plan completed, so this was installed. Now if I go here, I have an etcd available for me, and I can deploy new etcd versions. So same thing as the kube control that I've been doing here. I want to deploy an etcd version with the name of etcd cluster with the name of example. I want it size 3, and I want a specific version of etcd, in this case 3.2.13. When I create this, you will see that new instances will get created of that. We can go in the deployments. Here you see the etcd operator, and you can also see the example. This here is the example etcd node that was created. And so that one is ready. It's running. And now I'm able to, I can also go here. I can go here and decide instances. And I can see that. And I can see that it's coming up slowly. See, size 3 pods is what we asked. 2 are already here, so we're waiting for the third one. But this entire etcd cluster is bootstrapping itself and is able to then run. You can also see that it's sending back status. The cluster is available. What's the client port? How do I connect to it? What are my nodes? The members are ready. So all these pods are running now. You should be able to see them here. All these examples, I call everything example. I should fix that. But you have 1, 2, 3 etcd examples. And I can combine these things. I can also start doing a Prometheus one. So let's see. Prometheus is, for those who don't know, a very nice monitoring application. And that also can be instantiated with an operator. In this case, I start the operator again. Now I have it available here. Here I can do more things. I can not just create a Prometheus, but I can create rules. I can create the alert manager for Prometheus. I can create what we call service monitors. So let me create Prometheus first. So in this case, this is, again, the CRD for Prometheus is a bit more complex, so it has more inputs. But in the end, same API, I create it, and this is going to spin up a Prometheus cluster with 2 nodes, I believe. So, and then I'm able to then decide if I want to have it when I now go here, I'm able to compose things. So OLM, in this case, they are both independent, etcd and Prometheus, but one of the other goals of OLM is to be able to say, if my operator is going to require another operator, might as well find a way for them to request dependencies. For example, if I build something that requires etcd, I'm not going to build another etcd operator. I'm going to invoke a dependency to the etcd operator through the Lifecycle Manager, and then the Lifecycle Manager will install that for me first, or instantiate a version of it, and then deploy my application. And another kind of dependency is, for example, what we call a service monitor. If I want etcd to be monitored, for example, I can fill out this YAML that I have here. I can point it to the etcd instance, and that will allow me to then monitor the etcd instance. So, and all that, again, through the Kubernetes API. So the goal here is composability through knowledge, through existing APIs, and also to basically run applications in ways that weren't possible before, because you weren't able to easily combine them. You had to go through tons of steps to do that. So that's basically it for the demo. There's a couple of other things that I should note that I haven't talked about. So let's see. So the first thing is, how do you use this? Where do you find it? We have an Oregon GitHub. It's called Operator Framework. All the projects in there are open source. You can go there. The SDK has a nice getting started guide, which is kind of the same thing that I showed you today with a memcache. It's usable. There are current releases, and the Lifecycle Manager as well is there, as well as metering, and all kinds of future projects as well. So this is where things happen. Then you also have a couple of other places, like a getting started guide that is completely detailed, and then you can find us on the Kubernetes operators channel on Slack, or also on our mailing list. It's a Google group called Operator Framework if you want to participate, and there's some activity there. One more thing that I like to add that I haven't done inside of this is, we've seen how all of this was written with a lot of Go code. But for something as simple as memcache, and even for more complex things, sometimes you don't need all that Go code. Some people are more familiar with things like Helm or Ansible. The SDK allows that as well. There's a separate project called the Helm App Operator Kit that we're migrating inside of the SDK. It will allow you to take Helm charts and transform them into operators, and in the future probably also add custom Go code if you need to. This is not in the repo yet. The only thing that you can find is in there in the Operator Framework org. You can find the Helm App Operator Kit. And then the other great thing that we've added is you can write those operators with Ansible. And the thing that I want to show here is what it looks like. So the same memcache, we have a nice repo in the org called Operator SDK Samples, where you can look at examples. And an example of Ansible memcache is here. So compared to all that YAML that I showed you, this one is a bit simpler. You only have to define a few things. You have obviously what's going to be watched, but like the more interesting thing is that basically, without most of the boilerplate around this, the Ansible version of the same demo that I did boils down to this, which is very familiar to people who use Kubernetes, which is the definition about how to run memcache. And then the Ansible operator, instead of the Go runtime, does this. It uses the same code underneath, but it allows you to write much more YAML for those that prefer versus complex Go code. And in the future, also you'll be able to mix and match there if you need to. So this is not just for seasoned Go developers. That's the main thing. That was the bulk of the talk. So if anybody has questions, I'd be happy to answer. Yes? there's a mic coming.
Noticed in your demo that your CRD was in the same namespace as your deployed pods. Is this the pattern that we're going with, or is there a best practice for where your CRDs and operators should live?
Sure. So for simplicity of the demo, this was not something, I didn't do it how you should do it in production. This was all under the same namespace, under an admin user, and all of this. But as you saw, there's quite a bit of RBAC rules and things like this to deploy, and that's the reason. You're supposed to isolate things in different namespaces if you can. Now, the operators themselves, they can run in different namespaces. But the way we're designing things right now is Operator Lifecycle Manager instantiates one operator for the entire cluster, and then you're able to decide in what namespaces individual apps get deployed. Like, for example, the Memcache app. It was in the default one. I could have pointed it to another namespace if I wanted to, which you should do. Any other questions? Oh, it's back there. I'll wait for the mic.
So why would you use the Helm operator instead of tiller? What are the advantages?
So in this case, well, first of all, it doesn't require tiller at all. The goal here is it's really to simplify things. I don't think they're necessarily mutually exclusive, but we find that it was much simpler to generate a complete container that's self-contained versus relying on other external pieces. That's it. But with the future and how Helm 3 is going, things might change. I don't know. But that's it.